Here are your solutions to Lesson 10, Chapter 1, Guided Practice. First, we're asked, what number sets do each of these real numbers belong to? First problem is 0.050505, and it's obviously repeating. So because it is repeating, we could write it as a fraction, and that would be rational. Number 2, we have the negative square root of 64. Well, the square root of 64, we all know in our heads, is 8, so the negative square root of that would be negative 8. And negative 8 is an integer, and it is also rational. Remember, going out of the Venn diagram, and everything going up and out applies as well. So don't forget about rational there. We could write that as a fraction, is another way to think about it. Number 3, we have the square root of 17 equals, put that in a calculator, and we get 4.123105626, and it fills the screen, and it does not repeat. It does not repeat or terminate. In other words, that makes it irrational. Number 4, compare. So we have the square root of 15 and 3.5. Put the square root of 15 in a calculator, we get 3 and 87/100ths to the hundredths place, and we can see that it is a greater than situation. 87/100ths is greater than 50. Number 5, the square root of 2 1/4, or 2.25, and 150%. Well, the square root of 2 and 25/100ths is 1.5, and 150% is also 1.5. Therefore, we have an equal situation in this case. Number 6, we have the square root of 6.2 and 2.4 repeating. So 2.4 repeating, I just wrote it as 3/4 for now, just to check. Put this in a calculator, and I get 2.4899. Put extra digits there, you don't really need those. 48/100ths is greater than 44/100ths, or 489/1000ths is greater than 444. So we have a greater than situation. Problem number 7, they ask you to order and graph these numbers, these real numbers. Square root of 5, 220%, 2.25, or 2 1/4, and 2.2 repeating. So I wrote the 2.2 repeating with 3 decimals. This terminates, so we can just leave it at that. That also terminates, so it's 2.2. This in a calculator is 2.236 to the first 3 digits, and I think we can probably do it at that. So put the first one on the number line. We did 2 and 19/100ths, followed by 2 and 20/100ths, all the way to 2.28, and they will all fit on this number line. The square root of 5 is 2.236, so we go to 2.23. So 2.236 is going to be 6/10ths of the way from 2.23 to 2.24. So another 6/10ths puts that right there, and we mark that the square root of 5. Then we go to 2.2 for this one. So we're at 2.2 right on the head, and we mark that 220%. The next one is 2.25. We have that number exactly, 2.25, mark at 2.25. And lastly, 2.2 repeating. So it's going to look like this. So we go to 2.2, but now it's another 2/10ths to the this next place here is 2/10ths of the way from here to here. So move it slightly off the line, or 2/10ths of the way, 1/5 of the way, and mark that as 2.2 repeating. So now we have our 4 numbers in order. So our answer is 220%, followed by 2.2 repeating, followed by square root of 5, and then lastly 2.25. Number 8, somebody has figured out that you can calculate the area of a triangle if you know the 3 side lengths. So it would be the square root of s times s minus a times s minus b times s minus c, when s is 1/2 the perimeter. So you can take the length of the 3 sides, divide it by 2, and that gives you s. Okay, that's half the perimeter, and then you can take the side lengths a, b, and c are the side lengths. Okay, so then they say find the area of a 7, 9, 10 centimeter triangle. So the triangle has lengths of 7, 9, and 10 centimeters. So you add those all up. 7 plus 9 plus 10 will give you the perimeter of 26. Divide that by 2 to get half of it, and we have 13. So S equals 13. So now we just plug that number in here everywhere, and we can use this as A, B, and C. So we take 13 times 13 minus the 10 for A, 13 minus 9 for B, and 13 minus 7 for C. So we have 13 times 3 times 4 times 6. Put that all in a calculator, and it is the square root of 936. And the square root of 936 is approximately equal to, because we rounded this, 30 and 6/10 centimeters squared. Interesting problem. And lastly, our essential question: how are real numbers different from irrational? Now, first of all, we could answer this in a lot of different ways. I suspect some of you probably didn't come up with this particular one, but this is what they would like you to see about that. Think about it this way, and think about that Venn diagram. We have irrational over here, and rational, whole, etc. over here, and these are all real numbers. Okay, so the key thing to recognize there is all irrational numbers, that would be this strip over here on your Venn diagram, are real, but not all real numbers are rational. So if you, again, I'm going to draw a line here. Remember, we had irrational over here, and we had rational, whole, etc. So square root of 2, for example, is irrational, and it's still real, but we could take not all real numbers. So if we took the numeral 8 over here, or 0, or -8, or 3/4, none of those are irrational. So again, all irrational numbers are real, but not all real numbers are irrational.